Hello everyone, I welcome you all back to the another interesting session of Knowledge Hub. This is Lalita Devi, Senior Maths Faculty of Knowledge Hub by Sri Chaitanya. So coming to the today's session, we are going to discuss about the first chapter of our grade 8, which is nothing but our real numbers. So in our previous class, we have completed the discussion of what are the rational numbers and coming to the family of the rational numbers. Coming to the today's session, first of all, we will discuss about the standard form and comparison of rational numbers, and after that we will discuss the rational numbers between the given two rational numbers, and coming to the last of the session we will discuss how to represent the rational numbers on a number line. So first of all we will start with the discussion of the rational numbers. As we know that rational numbers are the numbers which will be represented in the form of p by q. So coming to here, if we consider the rational numbers, yes, so now the rational numbers are represented in the form of p by q, where both our p and q are the integers. So here we can write it as p and q belongs to the integers I, and another condition is q should be not equals to 0. Okay, so now if I am representing them in the form of rational numbers, means I am going to represent my numbers in the p by q form. And coming to the another difference, so mostly when we are talking about the rational numbers, one thing will come to our mind, that is nothing but your fractional numbers. So coming to the difference between the fractions and rational numbers is, if I want to represent my rational number, I can use any of my integers, like I can use minus 1 by 5. Okay, so where minus 1 and 5 belongs to the integers and my denominator 5 which is not equals to 0. But coming to the fraction, so as we know that fraction is nothing but a part of a whole. So that means if I am dividing my complete part into the 5 parts, I can take my 1 part or the 2 parts out of 5. But where we can't represent our part with the help of the negative numbers. Okay, why? Because coming to here, the rational numbers we can use the integers, where integers are having both positive and negative. But coming to the fractions, we are not using the negative integers. Okay, so that is the main difference between the rational numbers and the fractions. Moving to the next, if I am considering my p by q, I can multiply both my numerator and denominator. That is, p will be multiplied with m and q is also multiplied with m. Or it can be divided with n also. That means p by q, where p is divided by n and q is also divided by n. Okay. Now coming to the set of rational numbers or the family of rational numbers, we know that we are going to start with the natural numbers. Okay, so now all the natural numbers are considered as the rational numbers, where whole numbers and integers also considered as the rational numbers. But all rational numbers does not belongs to whole numbers or natural numbers like that. Okay, so now moving to the next, we will discuss about the standard form of a rational number. So in order to say that whether the given rational number is in the standard form or not, it must satisfy the two conditions. Coming to the first condition, we must and should have the positive sign in our denominator. And coming to the second condition, we are having the common factor between the numerator and denominator, which is only 1. Okay, so coming to the first condition, in order to say whether the rational number is in standard form or not is, the denominator should have the positive sign, and coming to the second condition, both the numerator and denominator are having only the common factor between them, that is nothing but 1. So that means consider that I am having an example of minus 1 by 5. So if you consider the denominator is having the positive sign, that means condition 1 is satisfied. And moving to the next condition, 1 and 5 are having only the common factor of 1. Okay, so it is having only the common factor as 1. So we can say that minus 1 by 5 is the rational number which is in the standard form. And if we consider another example, that is nothing but our 14 by 49. And if you consider the denominator is having the positive sign. But if you consider the common factor between the 14 and 49, it is having the common factor as 7. Okay. So out of the two conditions, it is satisfying the first condition, but second condition is not satisfied. Okay. So if I am taking my common factor, and if we are dividing numerator and denominator with the common factor, it can be further reduced as 2 by 7. Okay. So now coming to here, 2 by 7 is in the standard form, where 2 and 7 are having only 1 as the common factor between them. So now moving to the next one, let's solve a question on the standard form of rational numbers. So now express each of the following rational numbers in the standard form. So they gave us the 4 rational numbers and they are asking us to express them in the standard form. Now look at the first question. Coming to the first question, we are having minus 12 by 30. Okay, so coming to here, the denominator is having the positive sign, but both numerator and denominator are not having only 1 as the common factor. They both are having common factor other than 1. So we have to simplify that in order to get that into the simplest form. So now, if you observe here, 12 and 30 are having the common factor as 6. If you take your highest common factor, it will be of 6. Or if you take if you start taking from 2, you can take it also. Okay. So now 6 will cancel 12 for 2 times and 6 will cancel 30 for 5 times. Now on further simplification, the rational number will become minus 2 by 5. So now if you observe 2 and 5 are having only 1 as the common factor between them. Now let's solve the second one. Coming to the second one, we are having minus 14 by 49. So now the denominator is having the positive sign, but whereas the numerator and denominator are not having, are having other than 1 as the common factor. So now simplify the 14 by 49. So 7 will cancel 14 for 2 times and 7 will cancel 49 for 7 times. So on further simplification, we will get minus 2 by 7. And here the 2 and 7 are not having any other common factor other than 1. Now moving to the third one. So coming to the third one, it is of 24 by minus 64. So in order to convert the given fraction into the simplest form, we have to eliminate the negative sign from the denominator. How can we eliminate? On multiplying the numerator and denominator with minus, our minus in the denominator will be eliminated. So now it will become minus 24 by 64. Okay. So now if you observe here, 8 3s are 24 and 8 8s are 64. So now what it will become? Minus 3 by 8. So now 3 and 8 are having only the common factor as 1. Now let's solve the fourth one. Coming to the fourth one, it is given as minus 36 by 63. So now here also we are having denominator which is the minus. But minus in your numerator and denominator will get cancelled, so that we can eliminate the negative sign in the denominator. And now it can be further got as 36 by 63. Now we have to bring the common factor between numerator and denominator as 1. So that's the reason, let's simplify it. So on taking 3, it will become 12 and it will become 21 and once again 4 and it is 7. So on further simplification, it will become 4 by 7. Okay. So now 4 and 7 are having only 1 as the common factor between them. So if you want to represent any rational number in the standard form, first of all, we are going to eliminate the negative sign in the denominator, and next we are going to bring the given rational number into the simple form where our both numerator and denominator are having the 1 as the common factor. Okay. Both numerator and denominator should have the common factor as only 1, then only the rational number is considered to be in the simplest form. Now moving to the next, we will discuss about comparison of rational numbers. So comparison of rational numbers, mostly we will observe in the 2 different types. That is nothing but having the same denominator. So having the same denominator, and we are having the rational numbers that are having different denominators. Okay. So coming to here, we will discuss about how to compare the rational numbers if they are having the same denominators, and how to compare the rational numbers if they are having the different denominators. So coming to the same denominator, consider an example of 1 by 3 and 2 by 3. Okay. So here the denominators are same. So we can compare now our numerators. So 1 is less than 2. So therefore we can write 1 by 3 is less than 2 by 3. And moving to the next different denominators, like just consider 2 by 3 and another one is of like your 7 by 5. Okay. Now here if you observe, the 2 rational numbers are having the 2 different denominators. So how can we simplify it? Same like in our fractions, first of all we are going to make our denominator same, and then after we are going to compare the numerators. So in order to make the denominator same, we are going to take the LCM of our 3 and 5. So 3 into 5 will become 15. In order to convert the 3 into the 15, I have to multiply with 5. Okay, so as we are multiplying the denominator with 5, we have to multiply the numerator with 5. So it will become 2 into 5 will be 10 and 3 into 5 will be 15. Now moving to the next 7 by 5. I have to convert my 5 into the 15. So 5 is going to be multiplied with 3. As we are multiplying 5 with 3, we have to multiply 7 with 3. So it will become 21 by 15. Now if we compare here, we are having 10 by 15 and 21 by 15. So now if you compare here, 10 by 15 is less than 21 by 15. Okay. So not only for the comparison like greater than or less than or equals to, for doing the addition and subtraction also, we are going to make the denominator same in the rational numbers in order to add them or subtract them, or in order to compare them using the greater than, less than or equals to. Now moving to the next, let's solve a question on the comparison of rational numbers. Now fill in the blanks with the correct option, whether it was the less than, or greater than, less than or equals to. Coming to your first one, they gave that minus 5 by 7, fill it with 2 by 3. So now coming to here, the denominators are different. So we have to make the denominators same. In order to make the denominator same, we are going to find the LCM. So LCM can be given by 7 into 3, 21. So now I have to convert my 7 into the 21. That means I have to multiply my 7 with 3. So it will become minus 5 into 3 by 7 into 3. And coming to the 2 by 3, 3 should be converted into the 21. So it should be multiplied with 7. So now here it will become 2 into 7 by 3 into 7. So now minus 5 into 3 will give you minus 15, and 3 sevens are 21, and coming to here 2 sevens are 14 and 3 sevens are 21. Now here I got my denominators same, and if you compare the numerators, minus 15 and 14. So which will be the greater one? So most of us will think that 15 is greater than 14. So we can keep it greater than. But coming to here, we are having the negative sign for the 15. So negative sign means it will be of minus 15. Where minus 15 is less than 14, so now it will become minus 15 by 21 less than 14 by 21. Now let's solve for the next one. Moving to the next one, it is of minus 4 by 5 minus of, that means you have to fill the blank with minus 5 by 7. Okay. So now if you also compare here, compare the denominators are same. So we have to convert them into the same denominators. So our 5 is going to be multiplied with 7. See, coming to the another important thing, whatever the number you are multiplying in the denominator, you have to multiply in the numerator. Then only you will get whatever the given rational number. Okay. So that means if I am multiplying my denominator with 7, I have to multiply my numerator with 7. Okay. So in the same way, I am multiplying my 7 with 5. So I have to multiply my minus 5 with 5. So now 4 sevens are 28. So here it will become minus 28 by 35. And here it is minus 5 5s are 25. So minus 25 by 35. So now when you compare the numbers, 28 should be greater than 25. But coming to here, it is minus 28. So which is less than minus 25. Okay. Now let's solve the third one. Coming to the third one, it is given as minus 7 by 8. Fill in the blank with 14 by minus 16. Okay. If you observe here, coming to the second one, we are having negative sign in the denominator. So in order to eliminate the denominator, we can multiply our numerator and denominator with minus. So it will become minus 14 by 16. Now bring that into the simple form. Okay. Or you can convert this first rational number denominator 8 as 16 also. But here we are having the common factor between 14 and 16 as 2, and on division you will get minus 7 by 8. So now coming to here, we are having minus 7 by 8, which is equals to minus 7 by 8. Okay, so here we have to do multiplication or the division, means that depends upon the question. Okay, it means here if you observe here clearly, we can divide in order to get our another rational number. That's the reason I took the simplest form of the 14 by 16, which will become your minus 7 by 8, which is nothing but the another rational number. So we can compare these two with the help of equals to sign. Now moving to the fourth one. So coming to the fourth question, minus 8 by 54 minus 7 by 4. Okay, so in order to make our denominator same, you can multiply your 4 and you can do you can do LCM for the 58 and 4 and just give your answers in the comment section. Okay, now let's solve the next one. Moving to the next one, rational numbers between the two rational numbers. In order to find the rational numbers between the two rational numbers also, we are going to consider the denominators. If we are having the denominator same, we can proceed, and if we are not having the denominator same, first of all we are going to convert the denominators as the same number. Okay, so we can find the unlimited rational numbers. That means in between any two rational numbers we are having infinite rational numbers, and we can find the infinite rational numbers between the given any two rational numbers. So there you are having a bit that how many rational numbers you are having between any two rational numbers. So what we can say, we are having infinite rational numbers between the given two rational numbers. So coming to here, the conditions are whenever we are having the denominator same and when denominators are different. So if you understand when we are having the denominator same, the same procedure we will follow for the denominators are different. But another step, that means extra step, is nothing but you have to convert the denominator same in your second one. So now moving to here, when we are having the denominator same, just consider that we are having 3 by 8 and another one is the 5 by 8. I need to find my two rational numbers between the 3 by 8 and 5 by 8. So how can I write? Between 3 by 8 and 5 by 8, I am having my 4 by 8. Okay, so and it will become your 5 by 8. I found the one rational number. What about the another one? Because I need the two rational numbers. So for that reason, we are going to consider 3 by 8, but we are going to multiply our both numerator and denominator with 10. So it will become your 30 by 80. Okay, so why we are taking 3 by 8 multiplied by 10 means, coming to the properties of rational numbers, there we discussed about where p by q can be given by p multiplied by m by q multiplied by m. That's the reason. So coming to here, numerator and denominator is multiplied with same number. So from there you will get 30 by 80. In the same way, multiply our 5 by 8 also. So it will become 5 into 10 by 8 into 10, which is nothing but 50 by 80. Now we can easily keep the two rational numbers between our 30 by 80 and 50 by 80, where it can be taken as 30 by 80 and next 31 by 80 and 32 by 80 and 50 by 80. Okay, so this is the procedure we are going to follow if we are having the same denominators. Okay, and if you are getting the required number of rational numbers between two rational numbers, then we can directly write them. And if we are not having the required number of rational numbers, then you can multiply your both numerator and denominator with 10. Okay, so then you can get how many number of rational numbers you need. You can represent them between the given two rational numbers. Now moving to the next one is, what if we are having the different denominators? Like consider 1 by 2, another one will be the 2 by 3. Okay, if you observe here, 1 by 2 and 2 by 3 are having the different denominators, and I have to insert or I have to find the two rational numbers between them. So how can we find? So first of all, we have to make the denominator same. So that becomes 1 by 2 into 3 and 1 into 3. Now once again it will be of 2 into 2 by 3 into 2. So now 1 into 3 will become 3 by 6 and 2 into 2 will become 4 by 6. So after 3 we will get 4. But how can we insert the two rational numbers between these two numbers? Means we are going to take the 3 by 6 and multiply both numerator and denominator with 10. And same for our 4 by 6 also, multiplying with both 10. So now it will become 30 by 60 and here it will become 40 by 60. So simply now we can insert the two rational numbers between the 30 by 60 and 40 by 60. That becomes 30 by 60, comma, 31 by 60, comma, 32 by 60 and 40 by 60. Okay. So now moving to the next one, we will discuss the method of mean. So method of mean is nothing but we are going to take the help of the formula a plus b by 2. A plus b by 2. Okay. Where a and b are the two rational numbers that are given for us. So consider the same example 1 by 2 and 2 by 3. Now I need to insert the three rational numbers between them. So how can we insert? Our first rational number will become a plus b by 2. That means half of the a plus b. So it can be written as half of 1 by 2 plus 2 by 3. Okay. So now it will become half of, so 3 into 1 will give you 3 and 2 into 2 will give you 4. 4 by 6. Okay. So which is nothing but your 7 by 12. Understood? So this is nothing but your fraction addition only. That is 1 is going to be multiplied with 3, so will give you 3, and 2 is going to be multiplied with 2, so which will give you 4, and 2 into 3 will give you 6. Okay. Now coming to here, I am having my 7 by 12 between the 1 by 2 and 2 by 3. So how can I write 1 by 2, 7 by 12 and 2 by 3. Okay. I need to find the another rational number between them. So how can we find? Now I am going to take my a value as 1 by 2 and b value will become 7 by 12. So coming to the second rational number, between them will become, so second one will be half of 1 by 2 plus 7 by 12. So simply we can convert the 2 into the 12 by multiplying with 6. So that becomes 1 by 2 into 1 into 6 by 2 into 6 plus 7 by 12. So which will give you 1 by 2 into 6 by 12 plus 7 by 12. So now it will become 6 plus 7 will become 13. So it is of 1 by 2 into 13 by 12. So on doing the multiplication it will become 13 by 24. Okay. So now where we are having the 13 by 24, the 13 by 24 will lie between the 1 by 2 and 7 by 12. So it will become 1 by 2 comma 13 by 24 comma 7 by 12 comma 2 by 3. Still I need another rational number between these two. Now what we will do? We can take the 7 by 12 or the 2 by 3. Or you can consider 13 by 24 or 7 by 12. So now here I am considering between the 7 by 12 and 2 by 3. So our third rational number will become half of 7 by 12 plus 2 by 3, where 3 can be converted into the 12 by multiplying with 4. So now it will become half of 7 by 12 plus 3 4s are 12. So 2 is going to be multiplied with 4. 2 4s are 8 by 12. Okay. So now it will become half of 7 plus 8 will give you 15. So 15 by 12. So now on doing multiplication we will get 15 by 24. So finally the three rational numbers between the 1 by 2 and 2 by 3 will become, so 1 by 2 comma 13 by 24 comma 7 by 12 comma 15 by 24 comma 2 by 3. Okay. So we can use the method of mean. That means if it is not mentioned in the question, you can use whatever the method you want, like multiplying with 10 both numerator and denominator, or the mean method. But if they ask you in the question specifically use the mean method, means we are going to follow the mean method in order to find the rational numbers between the rational numbers. So this is how we are going to use the mean method. So here I am considering between the 7 by 12 and 2 by 3. And if you want to consider between the 3 by 24 and 7 by 12, it is your wish. Okay. If we are having the rational number, so this is our rational number 1 and this is our rational number 2, 3 and 4. Okay. If you want to take the mean for R1 and R2, you can take and you will get the another rational number also. That rational number also present between the 1 by 2 and 2 by 3. So now let's solve your question. So insert 5 rational numbers between the 3 by 5 and 9 by 5. So coming to here, what are the given rational numbers? So the given rational numbers are 3 by 5 and 9 by 5. So if you observe here, simply we can insert the 5 rational numbers between the 3 and 9. So what they will become? 3 by 5 comma 4 by 5 comma 5 by 5, which is nothing but your 1 comma 6 by 5 comma 7 by 5 comma 9 by 5. Okay, so I need the only 4. So they are asking 5, so it will become 8 by 5 comma 9 by 5. So here we inserted the 5 rational numbers between the given two rational numbers. So first of all, we are going to check the denominators here. Here the denominators are 5 and 5. It means we are having the same denominators. And now moving to the numerator, it is the 3 and 9. So between 3 and 9, we can insert the 5 rational numbers. That's the reason we are going to write the direct answer, and we can insert the 5 rational numbers between the 3 by 5 and 9 by 5 as 4 by 5, 5 by 5, 6 by 5, 7 by 5 and 8 by 5. Okay, now let's see. Coming to the next one, find 10 rational numbers between the 4 by 5 and 8 by 5. So coming to here, the given rational numbers are 4 by 5 and 8 by 5. Now, if you check the denominators, both the numbers are having the same denominator, that is nothing but 5. But if you compare the numerators, we are having 4 and 8. So between 4 and 8, we are having 5, 6, 7. So if I am taking my numerators as 5, 6 and 7, I am getting only 3 rational numbers. But they are asking us to find the 10 rational numbers. So how we are going to find? We are going to multiply our 4 with 10 and 5 with 10. And coming to the 8 by 5 also, 8 is multiplied with 10 and 5 is also multiplied with 10. So now 4 into 10 will give you 40 by 5 into 10 will give you 50. Now moving to the second rational number, 8 into 10 will give you 80 and 5 into 10 will give you 50. Now simply we can insert the 10 rational numbers between the 40 and 80. That is nothing but your 40 by 50 and 80 by 50. So you can take your first rational numbers like your 40 by 50, comma 41 by 50, comma 42 by 50, 43 by 50 and 44 by 50, 45 by 50. Like that you can take your 10 rational numbers or infinite rational numbers between your 40 by 50 and 80 by 50. Now let's solve the next one. Moving to the next one, find the rational numbers between 1 by 2 and 2 by 3. Up to now we have solved the two questions which are having the same denominator. But coming to this question, if you observe the given rational numbers, so the given rational numbers are 1 by 2 and 2 by 3. So coming to here, we are having the different denominators. So convert them into the same. So it will become 2 multiplied with 3 and 1 is also multiplied with 3. And 2 multiplied by 2 and 3 is multiplied by 2. So 1 3s are 3, by 2 3s are 6 and 2 2s are 4 and 3 2s are 6. Okay. Now they are asking find the rational numbers between them. If they are asking about the only one rational number, how can we insert? Why? Because 3 after we will get 4 directly. So there is no chance. So that's the reason we are going to multiply with 10. So it will become 3 into 10 by 6 into 10, 4 into 10 by 6 into 10. So now you can insert how many of your rational numbers are required between your 30 by 60 and 40 by 60. Okay. So there you can insert one rational number or two rational number like that. But what if I need more than 10? So from 30 to 40 we can take the 10 rational numbers between them. If I need more than 10, now you can multiply your 30 by 60 once again with 10. So that becomes your 300 by 10. Like if you need the 10 or 15 like that, once again multiply with the 10. So which will give you the 300 by 60, 600, and 40 by 60 is also once again multiplied with 10. So which will give you 40 into 10 will become 400 by 600. Okay. So now there is a possibility of keeping the 100 rational numbers between the 300 by 600 directly. So now moving to the next one. Find the rational numbers, that means 3 rational numbers between the 1 by 2 and 1 by 3 by mean method. Okay, so here they are specifically asking us to find the rational numbers by the mean method. So here we have to use the mean method only, because students will think that the procedure is very simple when we are multiplying with 10, but here they are asking specifically use the mean method. So we have to use the mean method in order to find the rational number. So first of all, we are going to take 1 by 2. So the given rational numbers are 1 by 2 and 1 by 3. Okay, I need to find 3 rational numbers. So first one, how can we find? So first one can be found by taking the average of a plus b. So that is half of a plus b. So it will become half of 1 by 2 plus 1 by 3. So now it will become 1 by 2 into 1 is going to be multiplied with 3. Okay, so that becomes 3 plus 1 is going to be multiplied with 2. So that becomes 2 by 2 is going to be multiplied with 3. So which is nothing but your 6. So this is nothing but your butterfly method of fraction addition. Okay, so that means 1 is going to be multiplied with 3, which will give you 3, and 2 is going to be multiplied with 1, which will give you 2, and the denominators are multiplied, so 2 into 3 will give you 6. Now coming to here, it will become 1 by 2 into 3 plus 2 will become 5 by 6. Now on simplification, it will become 5 by 12. Okay, so now I got my first number between the 1 by 2 and 1 by 3 as 5 by 12. Still we need to find the 2 more rational numbers between them. So I am going to take the mean between the 1 by 2 and 5 by 12. So coming to the second rational number will become half of 1 by 2 plus 5 by 12. So now we can convert the denominator 2 into 12. How can we convert? By multiply with 6. So it will become 1 by 2 into 1 into 6 by 2 into 6 plus 5 by 12. So now it will become 1 by 2 into 6 by 12 plus 5 by 12. So finally we will get 1 by 2 into 11 by 12. So which will become 11 by 24. Okay, so now once again we need to find the another rational number. So here I am going to take the mean between the 5 by 12 and 1 by 3. So coming to the third one will become half of 5 by 12 plus 1 by 3. So now half of 5 by 12 plus 3 is going to be multiplied with 4 in order to get 1. So it will become 1 into 4 by 3 into 4, which is equals to 1 by 2 into 5 by 12 plus 4 by 12. So now it will become 1 by 2 into 9 by 12, which is nothing but your 9 by 24. Okay, so we got finally the 3 rational numbers between the 1 by 2 and 1 by 3 are 5 by 12, 11 by 24 and 9 by 24. So now moving to the next, we will discuss about representation of rational number on a number line. So we do know that number line is the line where we are going to use, where we are going to use it in order to represent the numbers. So that is nothing but we are going to take a line, right? So we know how to represent the integers, natural numbers by taking our reference point as 0. So here I am going to take my reference point as 0. So if we talk about representation of integers, all our positive integers will lie on right side. So I am standing opposite to the number line. So it will become the right side. So here it is of positive and here it is of negative. Okay. So whenever we are representing the numbers on number line, we are going to take the direction like that. Number line is opposite to us and we are having the right side as the positive integers and left side as the negative integers. So coming to here, how can we represent the rational numbers on the number line means same like our fractions. So coming to the fractions, we are having the types of the fractions as proper, improper fraction and mixed fraction, right? So same like that, coming to the proper fraction means we are having the numerator less than the denominator. That is nothing but just consider 1 by 2. Okay, here the numerator is 1 which is less than 2. So now I want to represent my 1 by 2 on the number line. So we know that proper fractions will lie between the 0 and 1. So now here it is the 0 and here it is the 1. So now how can we represent the proper fraction on the number line means, what is the denominator? The denominator is 2. So that means we are going to divide the space between the 0 and 0 and 1 into the two equal parts. Okay. So that means this is the one part and this is the another part. Okay. So here I have divided my two equal parts. So here it will become your 1 by 2. Okay. And if you take another example, like you are just 2 by 3. Okay. 2 by 3 is also proper fraction. So now how can we represent it? So coming to the representation of 2 by 3, if you take your number line and here it is the 0 and here it is the 1. So whatever the denominator you are having, we are going to divide the space between the 0 and 1 into those many parts. So coming to here, it is the 3. So we are going to divide the space between 0 and 1 into the 3 equal parts. So now it will become your 1 by 3 and it will become your 2 by 3 and it will be the 3 by 3. And on cancellation you will get 1. So now they are asking us to represent the 2 by 3. So I am going to round it 2 by 3. Okay. Now coming to the improper fraction. So mostly improper fractions means we are having in the form of 11 by 3. So 11 by 3 improper fraction means here the numerator is greater than the denominator. So how to represent these improper fractions on number line means, first of all we are going to convert the improper fractions into the mixed fractions. So we know how to convert them into the mixed fractions. And on doing addition, so 3 will be the divisor and 11 will be the dividend. So 3 3s are 9. So 11 minus 9 will give you 2. So now whatever the quotient we are having, that becomes the whole number. And coming to the next, our remainder will become our numerator and denominator will be same. So now that means 3 3s are 9. 9 plus 2 will give you 11. So it will become 11 by 3. So now how can we represent the improper fraction or the mixed fraction on number line means, whatever the whole number we are having here, that will tell us these fraction lies between which two numbers. So here the whole number is 3. It means 11 by 3 lies between the 3 and 4. Okay. So 3 and 4. Now 2 by 3, we know that how to represent on the number line. So we have to divide the space between the 3 and 4 into the 3 equal parts. So it is 1, 2, 3. So now what it will become? It will become 3 1 by 3 and it will become 3 2 by 3 and it is of 3 3 by 3, which is nothing but your 3 plus 1, which is equals to 4. Okay. So now they are asking us to represent the 11 by 3 and the mixed fraction form is 3 2 by 3. So which is nothing but our 3 2 by 3. Okay. This is how we are going to represent the rational numbers on the number line by classifying it into the proper or improper fractions. Now let's solve a question on representation of rational numbers. Represent the rational number 5 by 4 on a number line. So what is the given rational number here? The given rational number is 5 by 4. So numerator is greater than the denominator. That means it is the improper fraction. So we have to convert that into the mixed fraction. So how can we convert? 4 will be the divisor, 5 is the dividend, 4 1s are 4 and 5 minus 1, 4 will give you 1. So now it can be written as 1 1 by 4. Right? So now how can we represent the mixed fraction on number line? First of all, we are going to check what is the whole number. So here the whole number is 1. That means 5 by 4 lies between the 1 and 2. Whole number will tell us what is the starting point of that given rational number. So take the number line. So here it is 0, 1 and 2. Okay. So the whole number is 1. So it means 5 by 4 lies between the 1 and 2. So now coming to here, the space between 1 and 2 is divided into the number of parts the denominator is having, which is nothing but your 4. So here it is 1, 2, 3, 4. So it will become 1 by 4, 2 by 4 and 3 by 4. Okay. So as we are having 1 by 4 after 1, it will become 1 1 by 4, 1 2 by 4, 1 3 by 4. Okay. Now they are asking us to represent the 1 1 by 4. So we are just going to round the 1 1 by 4. which is nothing but equals to the 5 by 4. Okay, now let's solve another question on representation of rational numbers. Which rational numbers does the letters x, y, z represent on the following number line? So here they gave the number line, and coming to here it is not 2, actually it is z. Okay, so here some of the points are represented by the letters x, y and z. So we have to give what are the rational numbers that are represented by the letters x, y and z. So first check for the x. Coming to the x, we are having them on the left side of the 0. So that means x and y both are the negative. Okay, and they lies between the -1 and 0. And if you look at here, we are having -2 by 5. It means the space between the -1 and 0 is divided into the 5 parts. So whatever the x you are having, the denominator should be 5. Okay, and coming to the y also, it is between the 0 and -1, and it is divided into the 5 equal parts. So therefore the denominators are 5. Now if you start looking from here, it is 0, so now it will become -1, and here the denominator is 5. So y value will become -1 by 5. Moving to the next, x value will become after -2. While moving towards the left, we will get -3, -4 like that. So here it will become -3 by 5. So x rational number is -3 by 5 and y rational number is -1 by 5. Now moving to our z. So z is on right side. So it is the positive value and it lies between the 0 and 1, which is the proper fraction. And if you look at the denominator, it is also divided into the 5 parts. But coming to here, we are having z after the second part. So it will be of third part. Okay. So our z value, that means the rational number which is represented by z, will be of 3 by 5. Now, moving to the next, represent the following rational numbers on a number line. So they gave that 3 by 7 and another one is the 8 by -5. So let's solve for the 3 by 7. Coming to the first one, they gave that 3 by 7. If you observe here, the numerator is less than the denominator. So it is a proper fraction. So proper fraction means it lies between the 0 and 1. So take the number line and here it is the 0 and here it is the 1. And coming to the denominator is 7. It means the space between the 0 and 1 is divided into the 7 equal parts. So 1, 2, 3, 4, 5, 6, 7. So here it is the 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. Okay. And why we are taking it as 1 means these one will become the 7 by 7 part. And on cancellation you will get finally 1. So that's the reason here we are going to represent it as 1. Now they are asking us to represent 3 by 7. So just round it off 3 by 7. Okay. And now moving to the next, 8 by -5. If you observe here, we are having the negative sign in our denominator. So we are going to eliminate that negative sign by multiplying both numerator and denominator with minus. So now -8 by minus into -5 will give you -8 by 5. Now keep your minus sign aside, and if you check the given rational number, it is of 8 by 5. So where the numerator is greater than denominator, it becomes the improper fraction. Now we are going to convert that improper fraction into the mixed fraction. So how can we convert? 5 is the divisor, 8, and 5 ones are 5, and 8 minus 5 will give you 3. So now what it will become? -1, 3 by 5, where our 1 is the quotient. So our whole part will become So coming to here, our -1, where 1 is the quotient and 3 is the remainder. So you can cross check it. Why? Because 5 ones are 5. Okay, 5 plus 3 will give you 8. So now here the whole number is -1. So it will be an integer, right? So -1 means it lies on the left side of the 0. So we are going to take the number line. So here it is the 0 and here it is the 1 and here it is the -1. Now it is of -1, 3 by 5. It means after -1 we are having the 3 by 5. So we are going to take up to the -2. So here I am going to take up to the -2. So I am having the given number between the -1 and -2, but I have to divide that space into the 5 parts. So it is of 1, 2, 3, 4, 5. So it will be of 1 by 5, 2 by 5, and 3 by 5, and 4 by 5. Where our 5 by 5 will give you 1, and we are having after -1, so that becomes -2. Now it is of -1, 3 by 5. So where we are having after 3 by 5, that means we are having the 3 by 5 after -1. So the value will become -1, 3 by 5. So now we are going to round it off. Okay. So this is how we are going to represent the given rational numbers on the number line. So now let's solve some of these simple questions on the rational numbers. Coming to the first one, the rational number -5 by -6 will lie on the left hand side of 0 on the number line. So they are giving -5 by -6. So minus and minus will get cancelled. So it will become 5 by 6. If you observe here, the numerator is less than the denominator. So it is a proper fraction. So proper fraction means lies between the 0 and 1. That is your +1. +1 means it is on the right side. But here they gave the left hand. So now it is of false. Now moving to the next one. All positive rational numbers are greater than 0. Is it true or not? All positive rational numbers. Why? Because coming to the rational numbers, positive numbers we are going to represent on our right hand side. So it will become true. Moving to the next. The rational numbers 1 by -4 is in the standard form. They gave that 1 by -4. Coming to the conditions of the standard form is the sign of the denominator should be positive, but coming to here the sign of the denominator is negative. So it is not in the standard form. Moving to the next one, the rational numbers -1 by 2 and +1 are on opposite side of 0. So that means if you take your number line, we are having 0 in the middle and +1 which lies on the right side, and -1 by 2. Negative values will lie on the left side of the 0. So it will be of -1 by 2 somewhere on the left side. If you observe here, -1 by 2 and 1 are on the opposite side of the 0 on the number line. So therefore it is given true. Coming to the next one. Every rational number is an integer. Is it true? Why? Because a rational number can be of 5 by 3. Where 5 by 3 is not an integer, right? So this is false. Coming to the next one, every natural number is a rational number. Natural numbers means the counting numbers, which are nothing but 1, 2, 3 and so on. I can write all my natural numbers in the form of rational numbers by taking the denominators as 1. It means the rational numbers are written in the form of p by q. Therefore, all the natural numbers, that means every natural number can be considered as the rational numbers. Therefore, it is true. Now moving to the next one, if p by q is a rational number and m is a non-zero integer, then p by q can be represented with the help of, so our p by q can be represented with the help of p into m by q into m. Okay, so which is nothing but your true. Understood? So coming to the rational numbers, if you understand how to represent the rational numbers on number line, it will be very easy because it doesn't need any steps. You are just going to convert the improper fraction into the mixed fraction. That's it. So moving to the next. So in order to know more about our courses, please go through this QR. And if you are having any further more doubts, you can go to the nearby offline centers. Okay. So that's all for today's session and we will meet in our next session. Thank you for attending.